Yeah. Hello everyone. So today we are solving a question from JEE Mains 2026, 28th Jan evening. And the question is, a student has been given 0.314 gram of an organic compound and asked to estimate sulfur. Okay. So we should underline this. Estimate sulfur. During the experiment, student has obtained 0.4813 gram of barium sulfate. Cool. The percentage, and also, yeah, this is also important that we have been given 0.314 gram of an organic compound. Okay, the percentage of sulfur present in the compound is, so this is our aim. So we have to calculate the percentage of sulfur in the compound. Okay, so this involves the chapter GOC. And okay, so, and this also involves estimation of sulfur using the Carius method. Okay, Carius method. In Carius method, what we do is we take a known mass of the substance or the organic compound and we heat it. Okay, so we take the organic compound and then we heat it with fuming nitric acid. Okay, and obviously all these things needs to happen in a sealed tube, so there should be a sealed tube which is also known as the Carius tube. Okay, so since we are doing this process, the sulfur which is present in the compound, so sulfur present in the compound, so that gets, so which is present in this compound, so that gets oxidized to sulfuric acid, that is H2SO4. Okay, and this sulfuric acid, to this we add excess of BaCl2. Okay, for a reason, because whenever these two guys react, we get a white precipitate of BaSO4. Okay, so we add excess BaCl2 so that the H2SO4 is precipitated as BaSO4, which is a white precipitate. Okay, so in terms of reactions, what we can, so we can write it as, so we take sulfur and H2O, since it is fuming nitric acid, and also we get 3 nascent oxygen from HNO3, obviously, because HNO3 is a good oxidizing agent also. So HNO3 contributes these nascent oxygen, and this leads to ultimately, obviously, heat symbol will be there and we'll be getting H2SO4. Okay, then we react this H2, so this is the first step. And the second step is we heat this H2SO4, I mean we react with this H2SO4 with excess of BaCl2, so that we can convert all the sulfur which is present in H2SO4 in the form of a precipitate called barium sulfate, BaSO4, which is a white precipitate. You must have learned about this in class 10th. Okay, so white precipitate plus 2HCl. And the precipitate of this BaSO4, after it has been formed, it is filtered, it is washed, it is dried, and it is weighed. Okay, so let's talk about the next step, that is calculation. So how we do the calculations. Okay, so let us say that in general, let the mass of organic compound is W, let's say it is W. Okay, and let's say mass of BaSO4 formed is X. This is the mass of BaSO4 formed. Okay, and seeing the reaction, I mean, we know, right, if we do stoichiometry, that 1 mole of BaSO4 contains 1 mole of sulfur. This is, we can see from the formula itself. 1 mole of BaSO4 contains 1 mole of sulfur. Okay, we know the molar mass of BaSO4, that is 233 gram of BaSO4 will give us 32 gram sulfur. Okay, so 1 gram of BaSO4 will contain 32 by 233 gram of sulfur. Okay. So therefore, let us say we have x grams of BaSO4, because we have assumed that mass of BaSO4 is found is x. So x gram of BaSO4 will give us 32 by 233 into x gram of sulfur. Okay, so this is the amount of sulfur present in. So this is the amount of sulfur present in W gram of the organic compound. Okay, so to find out the percentage, of a component of an element, we know the general formula. Percentage of an element in a compound, we know the formula. The formula is mass of the element divided by mass of the compound into 100. This is what we are supposed to do. Okay, so to find out percentage of sulfur in the compound, so what will we do? Obviously in the numerator we will have mass of sulfur instead. Okay, so mass of sulfur we found, it is 32 by 233 into x. So 32 by 233 into x, and mass of the compound that we have taken is W. Okay, x by W into 100. So this is the percentage of sulfur in the compound. This is the formula of Carrier's method in estimation of sulfur. Okay, now in the question, x, that is mass of sulfur, is given to us as 0.4813 gram, and W, that is mass of the compound, is given to us as 0.314 gram. So when we put these values in the formula, so we will have percentage of S is equal to 32 by 233 into 0.4813 divided by 0.314 into 100. And when we do this calculation, we get this as 21.05%. Okay, so the percentage of sulfur is 21.05%. Let's see which option is correct. Yes, it's the B option, 21.05%. Okay, thank you.